So hi, everyone. So I will be talking about machine learning. Thanks a lot for giving me the opportunity to talk about that. So it's a topic which is very close to my heart. And one point I would like to make is that, well, there are lots of high-profile applications recently, like conversational agents, like self-driving cars. But actually, machine learning is much more than that. It has an impact in a much wider range of domains. And essentially, it's like transformational. And I'd like to give you some examples of that today. We use machine learning, AI, not only like to scale up, create efficiencies, like increase raise the customer experience, but at the same time, then in the second part of the talk, I'd like to tell you about like some of the tools that we build internally and how we make them available to all developers so that you can start building on top of this work, and you can like start including machine learning in your applications. So to start, like with some background and give one example of automation, it's one of the first successes of machine learning. That's like, it dates back about 20 years ago. And it's called the net. And the net is one of those first like deep learning or like artificial neural networks. And it was used in the late 90s. It was used to automate like reading checks and verifying the numbers and automating that process. So what you see here is like on the top you have like, well, on the right side here, on the bottom you have like what the machine is seeing, and then on the top you see what the network is predicting of what is that number. And so on the left you have like some representation of different types of layers. That's not very important, but the main thing is that, well, this was developed in the late 90s, was used in the US, and was essentially reading about 10% of the checks at that time. And it was one of the first successes of this technology. So what does that mean today?
4 years ago, we started to wonder, what would shopping look like if you could walk into a store, grab what you want, and just go? What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart. If you change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically. So how does it work? We used computer vision, deep learning algorithms, and sensor fusion, much like you'd find in self-driving cars. We call it Just Walk Out technology. Once you've got everything you want, you can just go. When you leave, our Just Walk Out technology adds up your virtual cart and charges your Amazon account. Your receipt is sent straight to the app, and you can keep going. Amazon Go. No lines, no checkout. No, seriously.
So this is to give you a sense, like I give you an example like 20 years ago, how to automate like the reading of checks. And so here, this is like another level of automation and in fact of scaling. And so I wanted really to show this picture because I was there like, well, actually like last month. So I don't have like, I cannot just walk into the shop, so you need to be like this, like a beta testing. And so, but I was invited. And so I went to the shop and I was really impressed by seeing like how many people were like shopping in that shop, and the fact that people could invite me. So in fact, it's adding the complexity instead of just tracking one person, but you had to track two persons, and two persons were like picking stuff and putting that, and you had to track that in the cart. And so I was really impressed by this type of like making that possible. And at the moment, this is telling you like we automate that process, and then we have to deal with other challenges. Like at the moment, it was so successful that in fact we have like challenges keeping up with supply. So people like buy too much, and so the racks are essentially empty. So today, machine learning is creating, I think, a paradigm shift and has a big impact on industry. And like at a high-level concept, one of the reasons why this is happening is that when you look at traditional programming, well, you had like you have like data, you have like potentially you have data that you would like to process on the computer, and some developer or a group of developers is writing a program. And so the computer is ingesting the data and the program and produces some desired output. And you have like this kind of iteration going on, and you have to refine the program, think about all the edge cases. And in some cases, it's extremely painful to do. It can be very slow, and you need like a lot of iterations. So what's happening with machine learning and AI is that now you can look at the data in a more like the data and the desired potential outputs that you have. And by looking at these pairs of data output, you can execute some algorithm on the computer, which is going to produce, like learn the program, essentially. So once you have that program, you can then apply it again, like before, on new data and produce new outputs. So that's essentially what we call like learning and predicting. So the predicting hasn't changed, essentially. The only thing that's changed is how you get to this, like the program, essentially, which can you do now. In some cases, you can learn directly from the data. So what does that mean in practice? So, well, one example is named entity extraction. So this is one example that we use in natural language processing where, well, on the left you have some data. It's like some writer wrote like this story. And then we are looking for some annotations or an output. So we like, for example, in this case, we like to identify what are entities in the text. And so, of course, if you can have someone looking at the text and labeling, but that in some sense is not going to be very scalable, right? If you would like to apply to a large number of books or text, you have to find a way of automating that process. And so machine learning is helping us by observing the data and observing the output to learn a program that is going to be able to be applied to new documents and new text and identify entities. So you might wonder, why am I talking about like named entity extraction? Well, there are some interesting applications within the Amazon world. So for example, we can look at the Kindle. So in the Kindle, there is one of the tools that you have, or one of the features is X-ray. So an X-ray is like essentially enriching every piece of digital, written text data with other digital context. And so X-ray looks like this, so on the fire at least. So X-ray looks like this, where you have like on every page you can look at all the entities that are appearing, and you identify in which context they appear, so you have a short summary, and then you can start relating those entities where they appear in the book, or maybe on other sources like outside on the web, on Wikipedia or so. So this recognizing and being able to extract that information like provides like additional like features or additional functionalities to the customer. But obviously, if you look at books, well, we cannot have like an army of people checking every new book at every point in time, because there are just too many books that are added to the library every day. So you can take that a step further, and you can start looking at the same type of approaches in the context of video. So X-ray for video is kind of the same principle. So you analyze videos, and you identify who are the characters, who are the actors, and then you try to like identify which scenes they appear, and potentially link it to their IMDb page, for example. So you can find like some historical, some trivia, maybe some other movies where they're playing. So all those efforts, they do not like they do not happen overnight. And I think it's like, so there's like a lot of effort that goes into that. It's like a lot of, and it's being like a long investment in terms of work and in terms of complexity and scaling up all those techniques. And just to give you a sense, so if you look at recommendation search, well, this is the page of Amazon in the the mid-90s. And so that was already like all the recommendation tools are just initial first examples of applying machine learning. So essentially, AI was a tool that was trying to browse and predict and tell you what were the new releases that you would be interested in as a customer. Now we can use that today to also raise the customer experience. And so one of the things that we were looking at, like moving away from books, for example, we can say, like, can we potentially understand style and fashion? Can we like find ways of browsing apparel in a more natural way than just like you would browse? You have to find a very different way to recommend like a dress than you recommend a book. So are there more intuitive way of browsing, and can we learn ways of providing that information to the customer? And so we looked at some machine learning models like to analyze pictures. And so what we had like was this. So we have a target image, which is the top one on the left. And so we look at that picture, and then we find in our catalog what are the most similar items. So it's using text, it's using all sorts of information like image, etc. And the nice thing is that it's not only like it enables you to browse not only according, for example, to brand or size, but it also helps you browse according to you capture something like the style, the cut, the pattern, and not only like, for example, colors and things like that. So this is really things that you can start doing when you look at the data. You have some labeled data, and you can try to crank like some big algorithm that and try to get something out of that. What's like different reasons hidden in your data. And so we applied it in this case to apparel, but then we said, okay, well, maybe we can also use it to other types of products, and this was in the context of Amazon art, where essentially it's exactly the same algorithm. It's just like applying to different data, and there is no filtering at all. It's just like looking at the full catalog of anything you can buy on Amazon, and this is the type of recommendation that you get without any manual processing. So getting back to my point is like this is like a lot of effort, and machine learning and AI is really transformational. And at the moment, there are like probably thousands of people working on machine learning applications in all parts of the company. So that goes from like discovery and search, which are obvious domains, to logistics and fulfillment, like predicting, like forecasting demand. And we had also some examples this morning about like forecasting alerts or detecting alerts. So there are a whole bunch of people working at how you can better models for predicting demand, for example. I gave some examples of how you can enhance products, like in the case of the Kindle. And then, of course, there are like new devices, like Alexa is definitely powered by machine learning, and that enabled like some of the breakthroughs in recent years. And then finally, there's also, of course, there's like bringing machine learning to all and making ensuring that developers can make use of machine learning. And this is one of the things I would like to talk about, like in the second part as well. So you might wonder why is there a hype today? Why is this happening today? I mentioned this example of reading checks. That's like 20 years ago. So why now is there like people talking about machine learning and why is that making such a big shift in industry? So I think one of the things is this realizing that it's more than just those high levels, like a very high profile project. It's also transformational, and it can really help like in the back end and automating, creating efficiencies, and etc. But it's also because of the maturity of the technology. So one of the things is deep learning. Deep learning is one of, like it's a subset of the techniques in machine learning. And what happened is that, well, the algorithms, they existed for like more than 20 years, like even 30 years ago. So what's really changed recently is the data. So, well, you're probably very well placed to know that, but so in the last 2 decades or so, we started collecting data, all kinds of data, and so we have like a tremendous amount of data that we accumulated that we like to leverage. So that was not sufficient. So the second aspect is that there are some advances in hardware. So essentially like GPUs and some other hardware accelerations were introduced. And that made it possible to apply those algorithms to this very large amount of data. So if you're not able to ingest all the data, well, typically you're not able to capture and extract the patterns. So that's making a big difference. And then finally, which is more recent, is like there's a whole bunch of software tools that were introduced, and that makes it much more easy for developers, for example, to apply these techniques in there and incorporate that in their applications. Okay. So what about Amazon AI? So Amazon AI is essentially a suite of services that are powered by machine learning and deep learning, and I would like to talk about a couple of them. So I will not be able to talk about all of them, but I will talk about like essentially some like the deep learning framework, Poly and recognition. So Poly is like a text-to-speech service, and recognition is an image analysis service. So MXNet is essentially an open source project. So among all the existing frameworks, is the only one is the most open project that's out there, which I think is a very nice feature of MXNet. On the more technical sides, like it's highly programmable, so it's a relatively simple syntax, and you can easily interact with it with multiple languages, going from Python, C++, JavaScript. The other aspect is that it's executing on a large number of platforms. So it's very portable. It can be used on CPUs, on GPUs, can be used also on mobile. So that makes it very attractive in that respect. And then finally, the performance is really good. So in the sense that it's linearly scaling, almost linearly scaling with the number of GPUs, for example, which is not the case with the other frameworks that are available out there. So MXNet is the framework of choice of Amazon, and that means as well that you have like Amazon AMIs that were produced, so you can very easily use MXNet or other frameworks when you use like EC2, like they're pre-installed. You don't have to worry about configuration. It's very convenient for trying it out and making some like some initial like proof of concept and try to explore that space. The second one is Poly, and Poly is a text-to-speech service. And essentially, Poly, the goal is to look at text and just convert it to spoken speech. So it's the same technology as what powers Alexa, and it's available in a wide range of voices and languages. And of course, it's like low latency. So just to give you an idea of what that means, like how Poly is like operating, so this is one example, if it works. It doesn't work. Does the sound work?
Alice was beginning to get very tired of sitting by her sister on the bank, and of having nothing to do. Once or twice she had peeped into the book her sister was reading, but it had no pictures or conversations in it. And what is the use of a book, thought Alice, without pictures or conversations?
Okay. So this is just give you a sense of like this was written text, and then was just like the voice was produced based on that text. So more specifically, if you look at the challenges, there are quite a number of challenges that you have to deal with and that are addressed in Poly. And the first one is, for example, making sure that you're accurate in processing the text. That requires to understand a bit of the semantics.
Today in Seattle, Washington, it's 11 degrees Fahrenheit.
So in this first sentence, for example, you have to understand that WA is Washington. It's a state, and it's not like just like WA. You have to understand that what's a degree Fahrenheit? Well, at least this abbreviation. And this is like things that typically we would overlook in the first place, as humans at least we would overlook.
We live for the music live from the Madison Square Garden.
And so again, in this case, you have like, well, a word which is written the same way twice, but because of its use in different contexts, well, in one case it's pronounced live, in the other case it's pronounced in a different way. So again, you have like, so Poly is nicely taking that into account and able to handle that. The second aspect is like intelligibility, and probably, well, Poly is speaking slower than I am.
How much wood would a woodchuck chuck if a woodchuck could chuck wood?
I would not be able to say that. And then you have, like I mentioned about the semantics, so there's semantic in text, so you have to analyze the text to be able to read it properly, and then there are some more complex examples. So in this case, if you would not look at the semantics, well, if you have like this first sentence.
Richard's number is 2,122,341,237.
Would not be very practical, and so you have to learn that, and you have to discover and be able to infer that from the context.
Richard's number is 212,234,1237.
And then finally, you have also to introduce some specialized pronunciations, customized pronunciation, if possible. There are some cases where it's difficult to know in advance, and one example are, for example, names, where if you would not do anything, you would have this first...
My daughter's name is Kaja.
Would be pronounced in this way, while in fact it should be...
My daughter's name is Kaya.
So pronounced this way. So you have a way of customization, at least like for some specific vocabulary or specific names. So Poly is... So with this, I wanted to show you what are some of the challenges that you have to solve when you have such a service. And the nice thing about Poly that it's enabling you to have like new ways of interacting with your customers and probably like and communicating with your customers and essentially like building new apps that have that functionality. So the first one was on text. The second one that I would like to talk about is recognition, and recognition is on the visual side, like on image analysis side. So recognition is looking at essentially visual content and both like understanding visual content or like a searching visual content. So there is like one part is on scene analysis, so understanding what type of scene an image can be like and what's happening, what are the objects in the scene. And then a whole bunch of functionalities that are really focusing on face. So like face recognition, like identifying whether there is a face in the image or identifying which face in the image. And then analyzing what are the parts or what are the expressions, for example, in the face. Or then also, for example, doing a search of faces in a larger data set of faces. So again, like it can be used in real time. It's also available for batch prediction where you can send like a bunch of images and then you get out the analysis in one go. So let's look a bit more into object detection and scene recognition. So here in this case on the left, well, we have this picture of a beach. And there are some categories that could be predicted by analyzing that image. So you have like, this is a ranked list of potential items or attributes applying to that image. And so you have like, this is the ranked list according to some confidence measure. So well, let's say we're able to like predict, for example, that you have a bay, that there's a beach, etc. And then you see that there are some of the things that are more general, like a landscape. Well, we're still predicting well, but with like the confidence measure is going down because it's a more generic type of concept. So here you have first to understand like what's the scene, which type of scene you have, and then you can dive deeper into like what type of objects you might have in that scene. Like for example, the type of plant that are appearing there, like you have a palm tree. So they're very high confidence to having a tree in this image. If you look at the faces, so as I said, there's the first step is to identify whether a face is present or not, and that's not always trivial depending on the depth. And like a face can be small, can be bigger. But once you can recognize the face, well, you can identify the face, you can also recognize it. You might have some system where you want like to match the face to an existing database, or you might want to analyzing in more detail. And one of the things you can do with recognition is like to looking at, for example, things like emotion or some attributes again. Like you can predict, well, if there is like some particular emotion in that face, like in this case, calm with some confidence measure. But then you can also predict whether you have like sunglasses, whether the eyes are closed, etc. And all those kind of further analysis of the images. Okay. So with that, I gave you some overview of the MXNet, the deep learning engine, so which is like can relatively easily installing. There's an MI, as I said, like the functionality of Poly, which you look at text and produce speech and recognition of the image analysis. So there are a couple of other services, like for example Lex. So Lex is I will not go into the details because I don't have the time, but Lex is essentially automatic speech recognition and natural language understanding. And the big advantage of using Lex is that you can start building dialogue systems. You have like an interaction, and you can start like speaking to have apps that can speak, and your device can speak back essentially. So it's really opening up to a whole bunch of new functionalities, new types of apps, and the whole way of interacting with your customers that was not possible before. And then there is the last one, which is Amazon ML, so which is designed to build like smart ML applications. So it's really designed to help like developers building machine learning applications in other contexts. And the typical things like the things that I was mentioning at the beginning, like named entity extraction, are things that you can do very easily with Amazon ML. You can also start looking at fraud detection and all those kinds of standard classical machine learning applications. It's essentially helping, there's like some assistance tool and it's helping developers like embedding and using those functionalities. Okay. So overall, what I want to say is that, well, this whole suite of services are, of course, like low cost. They have like a high efficiency. They have very low latency, and of course, they can scale very well to like a very large data set. So if you're interested in learning about or trying it out, well, I can point you to the Amazon AI documentation. There you have like a lot of documentation for developers to how to get started. with any of those services. And if you're interested in what's coming up, well, I would recommend looking at the blog. So there's a blog, which is like the regular blog post, and you will know what are the all upcoming tools and new services and new features coming up in that space. Thank you.